What's the next step of this tutorial? Let's go back here. So we've accomplished this part, redo it for the list of elements. The next one is to export stress strain data for an element to a text file and then redo it for a list of elements. So how can I do that? First, I'm going to remove these because I don't want this information. That's all. It's confusing. I'm going to just select the list element, the 448 one. That's one element on the top of the specimen. And I want to export this information to a file. How can I do it? I can go to Report, XY, and then select these two information, go to Setup. Just remove this append to file, because if you do that and you have the same file name, it's going to add it at the bottom of it, and then you will have problem in MATLAB reading the file because it will have some other information at the bottom of the first set of raw data. You don't need that. So I'm going to just say that export it to this, and I'm going to give it the name, which was for this element number. Again, append file should be removed. I don't care for the maximum, minimum number or anything. I just need the XY data. And once I click OK, ABAQUS is going to create this text file for me. Where is it? This text file for me that has the time, the PEQ, and then the Mises stress. These are the information that I want. For example, in order to import to MATLAB and then compare the stress strain curves of these different elements, or I want to do some sort of post-processing on these numbers. So how can I do this for the list of elements? What I did was to basically, after the information of these XY data objects was created, I just did this thing, right? So I didn't do anything much. I need to go back to my file and see how can I export this information. So X0 was set as session this thing, which when you take a look at it, it's identical to this line that I was creating before, and X1 is again identical to this line that I was creating before. So I don't need any of these, right? And here I can say export to a text file, and this one was to save the plot. But I'm going to say, for example, here change the name to PQ Mises plus, oh sorry, plus strel num plus this thing. And here it was supposed to export X0 and X1. I don't have X0 anymore because I deleted them. I'm going to say XY1 and XY2, which was my Mises. So I'm assuming that if I run the whole thing again, it will export those information for me. Let's try and see if it's giving us any error. Delete these few lines because I want to have a fresh start. ABAQUS already knows what this EL list is, and you can check it. EL list, oh sorry, list, it already knows it. So I don't need to redo that line, but I can redo these lines. Oh, okay. So now I have an error. The error is saying that XY S Mises blah blah XY plot already exists. Again, yeah, okay. So the problem is sometimes you'll have some information that you don't need, and that will cause the problem. Can it be something else? No, I don't think that it can be something else. Oh, okay. So yeah, we may get the same error somehow. And the problem is with these XY plots, the combined ones, which, let's try and see again. Yeah, the same error. Because we already assigned this XY plot 7060 something. somewhere, and it cannot overwritten that line. The problem is with this line, XY session blah blah, or here. And to be honest, I don't need these lines anymore. So let's select this one, because we are trying to duplicate one thing, I mean the thing that we did before, to adjust something here that I don't want really to do right now. I can rewrite these lines in order to just export the text information. So if I do this, it will work, yeah, because I don't want to reassign different plots and everything here. You can change something here to avoid this error, but I don't want to do it right now. I just want these information to be saved as the PEQ information, PEQ Mises data, to different text files, which is working just fine right now. So I'm going to just delete these two lines and make two different loops. The first one is going to save the XY, stress strain plots. The second one is going to export those data points to a text file. The last thing I wanted to do was to save an animation for the Mises stress and redo it for PEQ, or I'm going to say another kind of graphs. So how can I do that? I need to go back to my specimen. See how does it look? Show the deformed. How does it look? That's fine. Go back to the RPY file. You're going to, what I did was to basically do these few things. I'm going to copy those, and here it's going to be save Mises animation, and I believe my primary viewpoint is PEQ. I'm going to switch it to Mises. So you'll see that on the RPY file again, this information is going to be changed. So I want these, and now I want to save the animation. In order to save the animation, you need to click on something like this. Then you'll see that the step time is changing, which is good. Remove these element edges, shows a more professional animation. And then I'm going to click here, save as, and here I usually change this Microsoft one to this one, if I can remember perfectly. Save. Okay, so now I want to give it a name. This is Mises animation. Let's change it to animation Mises. But one thing I want to point out is that because the total frames that we were having at the very beginning, which was similar to the field output, was only 50, the total frame in our animation can be 50. So if I use 24 frames per second, the total duration of my animation is going to be 2 seconds, which is really, really low. Now I want to have something like 10-second animation, so I can have a maximum 5 frames per second. Let's click on this, apply, and you should see some sort of rendering happening here. If you don't see that, probably something is wrong, and you need to investigate, see why it's not rendering for the animation. So I'm okay with this. It's going to just resave it because the first one I was clicking on apply. I could just click on cancel. And then I need to stop this animation because it's going to go until eternity. Now I need to go back to my RPY file and see what happened. So here was the line that I was changing the viewpoint to the Mises. From here to the rest is the one that I chose to save the animation, right? So what I did something twice, and I don't want that. I want to remove the last one. The last one, I believe, is this one. Okay, so these two lines are repetitive one, and I don't need those lines. Okay, so I believe that's it. Again, I don't need this line because the ODB is shown already. I can just change it to 01, and the rest should work just fine. If you want, you can check this one, save for PEQ animation, and you know how to change to PEQ viewpoint. You can just change the viewpoint to this thing. We already know that. This line will change the viewpoint to PEQ, and I'm going to show the deformed specimen, the viewpoint to the right, the undeformed to the right, then contour. And why I'm doing it undeformed and then right? Because I want to see the whole specimen. If I go to the deformed one and then right, I'm going to have the specimen filling up the whole space. Then when the animation is running, at some point I don't have the specimen, right? So I'm going to select this one, these few lines, and paste them there. And I'm going to just change this to PEQ. Okay, this line is something we don't need. Now, if I copy this thing, oh, and by the way, we can check the animation, see if we have an animation here, animation misses. If the animation is working just fine, then we can copy and paste these lines, and hopefully we'll be able to save the PEQ animation. Right, so it's working. Now, I'll paste those information here, and I'm seeing the rendering, so everything is fine. If it doesn't save you the proper animation, you either need to change the codec that you're using, or you need to change something else. Sometimes the problem is from this. Sometimes the viewpoint is not clicked, or the time history is not set. If you have, for example, the animation type scale factor, it's basically a different kind of animation. It's not going to show you the whole thing. So this is, for example, the scale factor, I believe. I don't know. So be careful to follow the step that I told you, and you're going to have the plastic equivalent strain animation properly as this one that you're saying. So for example, you can use this one for your presentation or something like that. Now that we are done, I want to add another step, and it's going to be running the animation or saving the animation in a loop. How can I do that? With the same principle of the element saving. So here I had a list of elements, and I was doing different things for a list of elements. I can redo the same thing for animations, for saving pictures and these kind of things by basically changing the viewpoint. So if I am in, for example, stress, instead of misses, if I'm in S11, and then I run the animation, I should see these kind of things. And here, I'm just interested in this specific line. So stop this, go back to the animation here, to my file, save misses. Let's just adjust this one. Let's just adjust this one, right? I want to save the animation for different kind of stresses. Here I switch to misses. Later on, I want to change to this one. So so integration point, and here I have a refinement invariant. Here I have the component, and then S11. So something is changing from invariant to component when S11 or misses is selected. So the principle is the same, but I want to save it for different ones. So save misses and S11, S22, S33. And I'm going to have a list, like stress list. Is going to be misses. I'm going to have S11, S22, and S33. And I'm going to have this one. So for S name here in S list, do this thing for me. The first thing is to switch. If S name is equal to misses do something, like auxiliary parameter should be equal to, what was it? Invariant. And that's it. I'm not changing anything else. And okay, so the first thing is to set this one as well. So let's save it here. The default one will be component, and if sname is equal to the misses, then it will be switched to invariant. The rest is going to be the same thing. So I'm going to have and I can place this information at the very top or here, but here is just fine. So don't switch this one. Here I'm going to have, instead of this invariant, I'm going to have something called AUX, which is one of the parameters. And here I'm going to have sname. Okay, so I believe everything should be fine. And it should work out just fine. Just be careful with your indentation. And I usually have the habit of putting a kind of comment line here, just to separate any loops or any if conditions from the rest of the code. And here I'm going to just change this thing from misses plus sname. Okay, so I believe it should work. Let's try it and see how it's going to perform, or even from here. I may have to add another two, like to show the ABAQUS that this is a string. I may need to do that, but let's see if it's working right now or not. Okay, syntax error, s, oh yeah, you're right. I didn't add this thing here. So copy this. Okay, now I have another error saying that the indentation is problematic somewhere. Where is that? It's session viewpoint, view 1, ODB displays, blah, blah, blah. So, oh, it's here. Okay, now I know why. So let's delete this one and see if it's going to save us. It's going to perform okay, or it's going to give us another error. But I know that I usually added that line somewhere. Okay, so the problem is with something else. ODB primary variable. So let's do this and see how does it work. And I'm going to delete this one. Oh, there you go. So yeah, now probably it will work. Let's see. Oh, and these two lines again should be closed, because the Python is going to follow the indentation. If the indentation breaks, it means that the loop is finished. The for loop is going to be finished. That's why it was giving us error, because of the indentation mainly. Now it's working just fine. So you'll see that the animations are going to be saved at the same folder, and you can change so many variables, so many things in your code. If you want to save different kind of things, you can assign different folders at the beginning, and then the whole loop is going to go over that. But now we have another problem here. It's saying that S11 primary variable selected environment not available. So something is wrong. AUX was this component. Oh, there you go. The problem is that for the first case, it was invariant, and then it was switched to components. So now this one will work just fine. Let's see. For the misses one, it went through that and it was working, but then the AUX was set as invariant, and it didn't go back to the component one. So that was a very simple error. And now it should work for all of those, as you can see here. So yeah, there you go. For example, for S11, it's showing us this, and etc. But since I clicked on one of the elements, the element is going to be shown on all cases. So that's done. Let's close this file and try to bring it back and run this script to see if it's going to go over all the things that we wanted to do without any error. But before doing that, I'm sure that I need to add this line as well from my previous tutorial to the very top, just in case later on we wanted to export some number values. And I may need to change this file a little bit, and if I do any changes, I'm going to give you the updated file. So now I'm back. I added a little bit more some details to this thing, and I wanted to have a neater and cleaner saving of all these files, because sometimes you'll save so many information from an ODB file that it can be complicated seeing and tracking those. So what I did was to basically go over this one again, and I've selected different folders. I named different folders, for example, image folder, animation folder, text folders, and I added those information in front of the file names. For example, this Mrs. image is going to be saved in image folder and then with the name image Mrs. The other one is again PEQ is going to be the same at that location again. For the PEQ Mrs. list of elements, it's going to be saved at image folder again, because this one was the images, but this one was the data that we were about to save. So this is going to be PEQ Mrs. data into a text file, into text files. And then we added those into a text folder. And for example, here we wanted to do the animation. We can delete this line as well. And this one was saved into the animation folder, this one into the animation folder again. So now, if I save this one, and assuming that this file is in the same folder as this ODB file, or you have a proper address of this ODB file. So here, the ODB file address and location is known. So you can easily run this file from any folder. So there is not really any relevance between the location of this file and this one. But if you didn't have the proper address of the ODB file, then these two files should be in the same folder, I believe. But you can play around with it and make sure. So if I run this one, and let's take a look. Be careful that you have to save all these folders. You can ask MATLAB to create these folders for you. And you can run the script. Again, run script, this one, and it's going to read the ODB file, do all the things that we asked it to do, and it's going to save everything in the proper folders. This one was the PEQ image, Mrs. stress image, all those stress strain curve data. And you can go, for example, into the text folders. All these texts are there, and animations are being saved right now. So that was all for this tutorial. Thank you and have a good one.